Hi everyone, welcome back to Powertronics session 5. I hope you are understanding all the concepts what we discussed in the previous sessions. If you are having difficulty to understand anything or you require some more clarification etc., so you can mail me or you can send the feedback to me also. That's fine. So continuation to the previous one, as we discussed in the commutation circuits, we require essentially like auxiliary thyristor, that's nothing but additional thyristor to turn off the conducting thyristor, and some circuitry element, especially elements like capacitor and inductor. So before going to discuss about the commutation circuits, I wanted to discuss one important circuit that's called as a tank circuit. Tank circuit is nothing but LC circuit where capacitor is initially charged. So we'll discuss, this is actually one of the important circuit for the commutation. So thereafter we will discuss all other commutation circuits based on the methodology and all. Okay, so first we will discuss about the tank circuit. To come to the tank circuit, I just wanted to introduce like with the normal DC voltage source, and then we will discuss about the actual requirement. Okay, so first like assume some circuit is given like this. So DC source and some mechanical. Assume DC voltage is something like VDC and the capacitor is already charged to a value of V0, initial value like this, and there is no initial energy in the inductance. That's what like you can say initial current flowing through the inductor 0, and this switch is actually closing at t equal to 0, and this inductance value L, capacitance value C. Assume we turn on this switch at t equal to 0, then what will be the current flowing through the circuit? That is what we need to find out first. So to calculate this, we need to go for the KVL equation. What's the KVL equation here? Voltage drop across the inductor plus capacitor voltage drop equal to source voltage. So what's the inductor voltage here? L into di by dt plus capacitor voltage is by C, integral minus infinity to t I of t dt equal to VDC. So this is a KVL equation. Now you can see that like solving in time domain, it is a little bit difficult. That's why we will actually going into Laplace domain, because one is in differentiation, other one is in integration. So in that case, so if you convert this into Laplace domain, you can see that, so this will be L into Si or S into I of S minus I0 plus 1 by C integration, that's nothing but a function f of S by S minus, because it is integrating minus infinity to t, that's what like we need to look at that what is there before switching, like turning on the switch. That means initial charge on the capacitor. Initial charge on the capacitor is C into V0 by S equal to VDC, C Vs, because it is a constant, so Laplace transform will be K by S. So now you can take common from this side, that's nothing but like you can take it as a I of S is common from two vectors, from this one and from this one. So then you will see that I of S multiplied with Ls plus 1 by Cs into S, that means 1 by Cs, okay, 1 by C into S equal to VDC by S. Okay, this is what, but here some factors are there, we need to take it other side. So I0 is nothing but initial current flowing through the inductor when switch is not in on state. That means, as we discussed already, like B by C gets cancelled, then it will be V0 by S. So that's what you will get. So now take out like whatever the equation from this, you can take out like I of s equal to, okay, and this will be, you can take it as a VDC minus V naught by S into, if you take this one this side, means it is 1 divided by LS plus 1 by CS. So that's what you will get. So now if you wanted to take this one further, simplify it, that means, so I of s equal to VDC minus V naught by S into, if you take the LCM, CS comes to the numerator, divided by LCS square plus 1. Okay, now we can see that SS gets cancelled, and here VDC minus V naught into C will be there. But now to take the inverse Laplace transform, we require like S square should have the multiplication of 1 only. That means you can take it the take the LC out. If you take the LC out, means CC gets cancelled, L will be there. So now you can rewrite this one as like I of s equal to VDC minus V naught by L into 1 by S square plus 1 by LC. Okay, so that's what the Laplace transform of that. Now I need to take care of the inverse Laplace transform of this. Inverse Laplace transform of this means I of t equal to, this is VDC minus V naught by L is constant, so take out the constant, VDC minus V naught by L, and you might have known that like 1 by S square plus A square is nothing but sin AT by T, sorry, sin AT by A. So you will get like that. That means here you can see that it is like a sin, in place of AT you will have a 1 by root LC square. That's why it will be T divided by root LC whole divided by A. A means 1 by root LC again. So you might have like why this is like this and all, means you can remember that. So here like what is the meaning of that one? So like Laplace transform of sin AT. So Laplace transform of sin AT is nothing but A divided by S square plus A square. So in that case, if you take again inverse Laplace transform of this one, means A divided by S square plus A square, that equal to sin AT. So here if you take this A here, means, so inverse Laplace transform of 1 divided by S square, so 1 divided by S square plus A square, so equal to sin AT by A. That's the meaning of that. So here in our case it is nothing but like a kind of like A is nothing but 1 by root LC. That's it, 1 by root LC. Then you can see that. Now we need to simplify this further. If you want to simplify this further, means, so I of t equal to so VDC by like here like VDC minus V naught by L as usual, and 1 by root LC comes to the numerator. That means VDC minus V naught divided by root L into root L. That means I am taking that L as a root L into root L into root LC into sin T by root LC. Okay, so that's what. So now here root L gets cancelled. So and 1 by root LC will be taken as a omega naught. That's nothing but it's a kind of like a resonance frequency in that. So now current flowing through the tank circuit or this given circuit will be VDC minus V naught multiplied with root L gets cancelled, that's why root of C by L into sine omega naught t. This is the equation we need to remember. Okay, so this is nothing but like current flowing through the circuit. What we like we have seen that current flowing through the switch. Now we need to calculate what will be the voltage across the capacitor. To know this one, we can rewrite that what we discussed in the one. So like what is the current flowing through the capacitor? I of t or IC of t, both are same. Switch current, inductor current, capacitor current, all are same. So IC of t equal to VDC minus V naught into root of C by L into sine omega naught t. So this is the current. Generally, voltage across the capacitor VC of t is nothing but 1 by C integral 0 to t I of t plus initial voltage across the capacitor V naught. Why we are taking like this means switch is closing at t equal to 0. Before closing the switch, we have the voltage, initial voltage across the capacitor, that's the V naught. But once the current start flowing through the capacitor, during that time voltage will be appear across the capacitor due to the current that is actually starting from 0 to t, and remaining voltage also we need to take care. So if you take that like 1 by C is constant, leave it. Okay, this is actually we need to integrate this with respect to t. So VDC minus V naught into root of C by L is also constant, so leave that one. VDC naught, so VDC minus V naught into root of C by L, that's a constant, take out the integration. So now sine omega naught t need to be integrated with respect to t, then it will be what's that, minus cos omega naught t divided by omega naught. Then we need to apply the limits. Limits are nothing but 0 to t plus V naught. So that's what we need to remember. Now we need to simplify this. How to simplify this? So if you want to simplify this means we can actually take that VC of t, that's nothing but voltage across the capacitor is. So here like root LC is there, root LC gets cancelled, then we will have 1 by root LC into VDC minus V naught. And here this is out like it is independent of the t, you can take it outside. If you take it outside means it will be divided by V naught. Okay, so now apply the limits. So limits, like we know that like f of d 0 to like a to b is nothing but f of b minus f of a. So first if you substitute t in place of t means you will have as it is, no difference. Okay, but when you are actually like applying this lower limit means in the actual formula minus will be there. Now minus is there, minus of minus plus, but cos 0 is 1, that's why you will have 1 minus cos omega naught t, okay, plus V naught. So that's what you got. So now further simplification, VC of t equal to omega naught is nothing but we have already taken that, it is nothing but 1 by root LC. 1 by root LC gets cancelled, that's why you will see that VDC minus V naught into 1 minus cos omega naught t plus V naught. So this is what actually, but still further simplification is there, so we can do that. So that's nothing but like because here minus V naught is there and then here plus V naught is also there, that's why you can do the further simplification. Okay, so now, so if you want to do this means VC of t equal to VDC, sorry, multiply that VDC into this one, that's nothing but VDC into So VDC into 1 minus cos omega naught t. Okay, that's what this one. Then we can actually take that like V naught factor. V naught factor is nothing but, like you can see that, so minus is there, minus into this one multiplication. That means minus V naught into 1 minus cos omega naught t. Okay, then you'll have this factor. So that factor you can take it as it is. So that's nothing but plus V naught. So now if you rewrite this one, and then finally you can see that voltage across the capacitor in the given circuit after turn on the switch is nothing but VDC into 1 minus cos omega naught t. And you can see that if you further expand, this means minus V naught into 1 is nothing but minus V naught. So minus V naught and plus V naught both will cancel out, and you will see that minus of minus plus V naught cos omega naught t. So this is the whole equation for the voltage across the capacitor in the given circuit. Okay, so remember this as we discussed already. So tank circuit is nothing but we need to look at without source voltage. So without source voltage is nothing but like a kind of, you need to, I'm actually redrawing the circuit, then you can understand. Discussed. So tank circuit is nothing but nothing will be there, like a kind of, like you can say that this is the tank circuit. That means no actual source will be there. This is tank circuit. You might have seen that this is required in case of oscillators. Okay, so tank circuit. So now what are the equations we discussed? The same equations we need to apply, but we already discussed in this case like a current flowing through the switch after turn omega naught t. Okay, that's a current. And voltage across the capacitor we already discussed, that is nothing but what we discussed. Now in this same thing you can see that both are same, but only the difference is here. You can see that this circuit is actually having the DC source, but this circuit no DC source. That means same equations you can take that in tank circuit there will not be any source voltage. So now if you rewrite these equations, then these are the tank circuit equations. You need to remember these things. That means current flowing through the capacitor is I of t equal to, so here VDC 0 means negative. Why it is negative means in this case source is supplying the current, but now once you close this switch at t equal to 0, then capacitor will act as a voltage source and it will start supplying the current like this. That's why reverse direction. So that's the meaning of that. Now forget about the direction of the current, then it will be initial voltage across the capacitor into root of C by L into sine omega naught t. Likewise, capacitor voltage is nothing but this entire will be 0 because VDC 0. Then you will have VC of t equal to V naught into cos omega naught t. Okay, so these are the equations we need to remember for tank circuit. So these are very important equations. That means in case of tank circuit, current will actually follow the sine wave, voltage across the capacitor will follow the cosine wave. Okay, so these are some things important for us. Okay, I'm stopping here in this session, then we will start with the other session with the commutation circuits. See you there.